Welcome. This question says, picture throwing a cubic meter of lead into a swimming pool. Now picture throwing a cubic meter of styrofoam into the swimming pool, and which has the bigger buoyant force. So if we picture this is the swimming pool surface, and we have basically a cube of lead, and then we throw in styrofoam. It's not actually going to float like this, but it will float. So we want you to be realistic in your picturing. So often we don't care about, we try to make things pure, and we get rid of things like air resistance. But on this question, we want you to be very pragmatic. The buoyant force, well, there's a buoyant force here. We'll call it F B-U-O-Y, and there's also one here which is F-B-U-O-Y, and in both cases F buoyant force is equal to, well, it's the density of the fluid times G times the volume of the displaced fluid. Now if I look at this, well, let's say the buoyant force for lead, and then let's over here say the buoyant force for styrofoam. It also equals, well, it's the density of the fluid times G times the volume of the displaced fluid. So in both cases we have the density of the fluid, so there's no difference there. In both cases we have G, there's no difference there. But the volume of the displaced fluid, in this case, the entire block submerges. And so the volume of the displaced fluid is as big as the block. So F buoyant for lead is equal to a big number. Whereas for the styrofoam, we can see just from our visualization that the volume of the displaced fluid, styrofoam will hardly have any volume beneath the surface, is going to be small. So the F buoyant for styrofoam is, well, the density is the same and G is the same, but the volume of the displaced fluid is much less. So this would be small. It seems counterintuitive. The thing that floats has a small buoyant force, and the thing that sinks has a big buoyant force. And that's frankly because we tend to confuse buoyancy and buoyant force. The reason why the lead sinks is because even though it's got a big buoyant force, it's got a huge weight. And the reason why the styrofoam floats is because even though it's got a small buoyant force, it's got a tiny weight. So we've got to distinguish between buoyancy, the tendency of something to float or something to sink, with buoyant force. Buoyancy is basically the net sum of these two guys. I try not to talk about buoyancy very much. This has a small buoyancy, negative buoyancy because the weight is bigger than the buoyant force. This has a big buoyancy because the buoyant force is much bigger than the weight. It's a tiny buoyant force but it's an even smaller weight. So don't get confused between buoyant force and buoyancy. And there we have it.